Hello everyone, and welcome to the third video in this tire mini-series. We're going to take a small break from vehicle dynamics and talk a bit about trackside performance. Particularly, we're going to go over proper preparation procedure for race tires before and after a stint on track. This will by no means cover every little task of a tire guy or girl, but will focus on what directly affects performance for most race series. So to briefly motivate what we are doing, we want to prepare our tires in a scientific manner, which is consistent every time. This will help us extract consistent performance in the very inconsistent world that is a racetrack. Finally, if we do this right, we can begin to use the physical tire as a method of measuring car performance. This is a topic that is very special to me. For those that don't know, I started off my career in racing as a tire guy for Ian Lacey Racing, running GT4 and GT3 cars in GT World Challenge America. I simultaneously also took several contracts in IMSA and had the privilege to work with many championship winning teams. This led to my big break contracting as a tire engineer for Pirelli Motorsport. Here I am in this picture clearly enjoying a very cold and wet race in Sonoma, California. Fun fact, this is one of the trickiest tracks in the world to get your tires dialed in at due to track geometry, dust, and a massive morning to afternoon temperature difference. So, getting right into it, we need to talk about the different options for inflating our tires. We can pick from pure nitrogen or air. Air is a mixture of different molecules, mostly nitrogen and oxygen. It also has a tendency to get mixed up with water vapor. We call this humidity, and we measure it in percentage of its total carrying capacity, which varies with temperature. The higher the temperature, the more water and air get along. Inside a tire, this can be problematic as this water can boil and turn into high pressure steam. Additionally, it's worth noting that the oxygen component of air has a tendency to permeate right through the rubber of the tire. This is because oxygen is a small molecule and rubber changes shape when heated and stretched. Thus, for most professional racing series, we use pure nitrogen because it reduces loss of pressure due to the permeability of oxygen and rubber. We typically pre-order nitrogen in these steel bottles from a company called Airgas. Wisdom requires me to share with you to always keep the valve closed when not in use and secure the bottle to a rigid object that won't move. These bottles weigh about 200 pounds and have over 2,000 psi of nitrogen in them. That's a lot of potential energy, and these can become projectiles if abused. Mythbusters actually did an episode where they launched one through a brick wall. Unfortunately, however, even switching to pure nitrogen doesn't totally solve the humidity issue, as atmospheric humidity can enter the tire during the mounting process. Thus, we purge and sometimes even vacuum our tires. This is a process of inflating the tires with nitrogen and letting them deflate or vacuum below atmospheric pressure. This photo is of a system I built to do all 4 tires at once. I built this with all Harbor Freight parts, so it's quite affordable. If you're really interested in following this humidity rabbit hole, you can consider getting a hydrometer. It measures temperature and humidity. Do be warned though that it can take a while to read and it might severely deflate your tire by the time you get the information you want. Finally, if you're very deep into the humidity thing, you can also use a desiccant filter, which will further dry out the nitrogen before making its way to the tire. If you are planning to just use compressed air instead of nitrogen, I strongly recommend getting one of these as most air compressors I've seen have a puddle of water inside them. As for tire pressure, it's mostly up to the manufacturer specifications. Most teams will try to run as low pressure as possible without getting either a penalty or a tire failure. Either way, it's really important to have a good tire pressure gauge. Digital and from a good brand is a must for any professional. I personally like Alfano, as this gauge lets me save my readings and also measure tire surface temps, which I then share with my team's race engineer. Another handy feature is being backlit. Importantly, it's crucial to keep track of how the pressure changes with temperature. For these large temperature differences experienced on race cars, the ideal gas law does not apply. You cannot assume linear pressure growth here. If anything, it is closer to exponential growth. Speaking of temperature, in many racing series, preheating of the tires is required. GT3 racing provides you with a couple options of how to accomplish this, the first of which is tire ovens. The red cannon on the right-hand side is a kerosene heater which blows hot exhaust gases through some pipes on the bottom which direct the heat upward. This particular example is from Greaves Engineering, a UK-based company. I personally worked with these and can say that at very high temperatures, above the recommended amount, these start to disintegrate and make a huge mess. However, the biggest problem I've had with these is battling uneven heat distribution. The top tires tend to be a lot hotter than the bottom ones. I was able to mitigate this by installing an external fan behind the heater, which would keep circulating the gas inside the oven even when the heater is off. It also helps to install an external thermostat, which controls the heat inside to a desired setting. The other option you have is electric blankets. These are what they use in F1. They're easier to transport and don't leave the pit lane covered in smog. Some info worth knowing about these is that if you stack the tires with blankets on them, the heat travels upward and you again get a really hot top tire and a cool bottom one. In a configuration as shown though, the heat distribution is pretty even and you can start setting pressures closer to the operating temps, which helps with that non-linearity issue. One more thing about these is that they can catch on fire if you don't handle them properly. They need to be opened up and allowed to cool after each use. So now we're ready to run the car. Let's discuss some measurements we can now make to determine how our tires operated. Tire scraping is a process of heating up the rubber either with a heat gun or torch and using a putty knife to scrape off the dead rubber, revealing the wear holes, which in this picture are circled in red. The depth of these wear holes are measured and compared to an initial value before the tire was used. The goal is usually to reach even wear across the tire, which can be accomplished by adjusting pressures, camber, and driving. For example, a tire that has concentrated wear in the middle can be a symptom of too much tire pressure. A tire with concentrated wear on the inside edge has too much camber, and vice versa. Similarly, the surface temperatures of the tire can be measured during the run to give insight into how well the tire is working. Shown here is an infrared laser setup which mounts onto the car and can be streamed via the car's telemetry system. Also popular is the thermocouple pyrometer probe, which you manually place on the tire for a reading. This is a decent budget-friendly method, but I actually really dislike it as it is quite biased to the last corner before the pit lane. And depending on how long your pit lane is, the tire could have cooled significantly. My personal tire gauge, the Alfano on slide 33, actually has one built in. That's the yellow cable with the sharp little point. Moving on to tire failures, I'm not going to spend too much time on tire failures, but I do think that if you're going to have time beside a racetrack, it's good to know about them and how to identify and avoid them. I can make a whole separate video about the topic, so if you want that, please let me know. Briefly, graining is the most common issue in GT racing because we predominantly use hard compound tires. I'll expand on this in the next slide. Blisters are when a big chunk of rubber rips off the tread, typically caused by improper thermal management and using too soft of a compound tire. Flat spots are from wheel lockups. Sidewall collapse, sometimes called flipper failure, can be caused by several issues, but are usually attributed to too much camber and heat without enough pressure. These can sometimes be manufacturing defects. If you see a bubble on the sidewall of the tire must be replaced immediately. Overheating, referring to poor tire preheating methods, this can cause your tire to turn blue, which is a side effect of oils in the rubber compound burning off and hardening. Punctures are pretty straightforward and occur from the tire making contact with the debris on the track or with another vehicle. Many times, punctures occur in the paddock on the way to the track by a screw on the ground, so I always advise to get a really crappy set of tires to roll to pit lane on, and then replace them before the session. This actually also makes good pit stop practice. In the end, the most common cause of tire failures is too much heat and not enough pressure. Tires are built at around 150 degrees C, and it takes that much to take one apart. Now, because graining is so common, I do want to spend some time focusing here. The ripple pattern you see is from tiny bits of rubber falling off the tread and immediately gluing back on. It occurs for much of the same reasons as blistering, but is localized to much smaller areas. Making it go away is a bit tricky, but is usually caused by an imbalance of temperatures between the track, tread, and carcass. Sometimes an easy warm-up lap solves the issue, but you may need to adjust suspension and alignment setups to see improvement. It's worth trying to solve this problem because it causes increased wear rates and grip loss. In the next video, I'll be showing what real data from some of the above metrics looks like, as well as introducing ways that we can use the telemetry package to assess tire performance. Please remember to like, subscribe, and hit the bell icon, and I'll see you in the next one.